Our next subject in organic chemistry is to talk a little bit about these things called isomers. Now, what is an isomer? An isomer is a molecule that has the same chemical formula, but different arrangement. And we're going to do pentane to start. Pentane looks something like that. It's 5 carbons in a row. And what I'm going to do is I'm going to take it. Actually, here, let's get our formula. It was C5H12, if you count that up right. And what I'm going to do is I'm going to take that thing. I'm going to break the bond right here. That's a carbon here and a carbon here. And I'm going to break that bond between it. I'm going to stick that carbon way over here to that carbon on the left. And it's now going to look something like this. I've got the 4 carbons that are left, and then I'm going to move that 1 carbon to be sticking up over here. We still have 5 carbons, and if you count 3, 6, 9, 10, 11, 12, you still have 12 hydrogens in there. Same formula, but definitely different connectivity, right? It's a different arrangement of things. The longest chain I have here is these 4 carbons in a row. There's no carbon chain of 5 anymore. And so this is what we call an isomer. These are isomers of each other because we broke a bond, moved something around, and it's now a different molecule even though it has the exact same chemical formula. And so what I'm going to do is I'm going to demonstrate that with this molecule that I have right here. Here is C5, 1, 2, 3, 4, 5, H12. And I'm going to do what I did. I'm going to take this guy off here. I have to make that little snapping sound. And then actually I have to take off a hydrogen over here, which I didn't show you because we don't have to show hydrogens in the condensed form or in the skeletal formula. And I'm going to make it look something like this. And so now I've got a very different molecule, right? I don't have just that same thing that I had before. This is very different looking. It's not a chain of 5 anymore. It's a chain of 1, 2, 3, and 4, and with this other one sticking up top. But still, it's C5H12 if you did all of that counting. So those are what are called isomers. And in order to make an isomer, you have to break a bond, and then you have to make a new bond somewhere else. But it turns out there's also other things that these organic molecules can do. So I'm going to go back and make my pentane again. And you can see I've got my up, down, up, down. And what I'm going to do is, I'm going to try to do this in front of the camera, is I'm going to just kind of rotate this guy up front like this. Now, I'm going to rotate this guy up like this. Now, does it look like up, down, up, down, up, down anymore? No, it doesn't. It looks like this kind of jumbled mess now that's really hard to interpret when I'm kind of holding it up to a camera and wiggling it around and making it all fuzzy. Right? So it's not this kind of regular structure anymore, but I could rotate it back and get my up, down, up, down, up, down if I wanted to, just like that. So what did I do there? Well, what I did there is I took my pentane, and instead of breaking a bond, I just rotated a bond, maybe. Oops, and got something that looks like that. Still C5H12 on each one of those. But what I didn't have to do is I did not have to break a bond and form a new bond. I just had to rotate this thing around. And it turns out these hydrocarbons are very floppy molecules when there's all single bonds present. These are not isomers of one another. These are exactly the same molecule. They are no different. They don't have different chemical properties. These two up here that are isomers, they actually have different chemical properties. They'll melt at a different temperature. They'll react differently, even though they have the same chemical formula. These two are not called isomers. They are called conformers. And they are just rotations of a molecule, but no breaking of bonds. And it's still pentane, it's still C5H12. And in fact, in the real world, what this thing is doing is it's constantly just rotating and moving around and doing all of these things. So it takes on all these different shapes. When we draw it up, down, up, down, up, down, that's just for us to simplify things, but it's not actually what the molecule is doing. It's flying around and moving like crazy. So isomers, you break a bond, make a new bond. Conformers, you just rotate around bonds, and it's the exact same molecule. So I'm going to show you a picture here next And what I want you to do is try to identify which of the following are isomers. Oops. Which of the following are isomers? So what did I have to do? In which pair of these did I have to break a bond and make a new bond? So think about that for a minute, pause the video, and come on back. Alrighty. Hopefully what you did is you said, well, in order to make an isomer, I had to break a bond and make a new bond. And so one of the easiest ways to tell, did I break a bond, did I make a new bond, is to say, well, let me count how many in a row we have. In Q, we have 1, 2, 3, 4, 5, 6 in a row. In R, we have 1, 2, 3, 4, 5, 6 in a row. In T, we have 1, 2, 3, 4, 5, 6 in a row. In S, we have 1, 2, 3, 4, 5 in a row. I can't get 6. There's a 6th one over here, but it's not in a row. And the only way to get that is to break a bond and move it around. So S has to be one of my things that is an isomer pair, and the only one I gave you is S and Q. It turns out S and R are isomers, S and T are isomers, but I only gave you S and Q as an option. So those are how we identify isomers versus conformers. Q, T, and R are conformers of each other. They are just rotations of the same molecule. All right, thank you.